Welcome to the Ultimate NumPy course. This course is designed for all Python enthusiasts. Whether you are a complete beginner with no prior experience in data science or Python, an intermediate user aiming to enhance your data manipulation skills, or an advanced learner eager to master NumPy for more complex data operations. In this course, you will learn everything about NumPy, which makes you ready for data science, machine learning, and AI. This course is divided into 4 chapters. We will start from scratch, showing you how to set up NumPy on Windows and macOS, and jump right into the powerful NumPy arrays, the core of data manipulation in Python. You will master creating and exploring arrays, from simple 1D arrays to complex multidimensional arrays. Next, we will guide you through NumPy amazing functions to transform, reshape, and analyze data. Then you will learn how to slice and index arrays like a pro. Whether you are working with simple 1D arrays or complex multi-layer data in 2D arrays, we will explore fancy indexing and techniques to assign values, ensuring you can access and modify data with ease. And of course, we won't skip the essential operation in NumPy, from filtering data with condition to performing arithmetic and statistical operations like sum, mean, and standard deviation. Whether you are calculating maximus, doing element-wise multiplication, or logging values, NumPy has it covered. Each chapter is packed with practical examples and clear explanation, making it easy for you to get hands-on and start applying what you learned immediately. In this section, I am going to show you how to create a virtual environment, set up a Jupyter notebook, and install the NumPy library. So here I have created a data science folder, and I am going to open this folder in command prompt on Windows. So I will type here cmd. After this, within this command prompt, you need to type a specific command to create a virtual environment. And the command is a python m then v, and after this specify the name of the virtual environment. In this case, I am going to give a virtual environment as a DS, which stands for data science, and you can specify any of the name that you want. And after this, hit enter, and it takes some time and create a virtual environment. And if you see something output like this, which means we have successfully created a virtual environment. If you are not sure, specify here dir, and you can see here we have the folder ds. And now to activate this environment, or if you want to work within this environment, you need to activate this environment. To activate this, specify the virtual environment name like this ds, then slash, after this specify scripts, then slash, then specify activate, and then hit enter. As soon as you hit enter, you see something like this. Within a parenthesis, you see virtual environment name. That means you are actually within that environment. That means we have successfully activated the virtual environment named DS. And now let's set up the Jupyter notebook. And Jupyter notebook is a kind of IDE for data science, or that allows you to run Python code in multiple cells. Just think Jupyter notebook is like a IDE. So here specify pip install notebook and hit enter. Okay, now if you see output like this, which means we have successfully installed the Jupyter notebook. Next, let's install the NumPy. So specify here command pip install NumPy and hit enter. And remember, the package that we have installed like Jupyter notebook and NumPy will be installed this environment, DS environment. As you can see, it downloading the Python NumPy version 2.1.2, and look, it shows successfully installed the NumPy. To verify it, specify command pip show NumPy and hit enter. You can see it shows NumPy installed successfully. Just go up and you can see here package name is a numpy, version is 2.1.2. so this means we have successfully installed the numpy. Now here let's open the Jupyter notebook, specify here Jupyter notebook and hit enter. And now this is the user interface of Jupyter notebook, where you can create a notebook and execute a Python code in that Jupyter notebook. So to create a new file or new Jupyter notebook, click on this new and then choose the Python 3, and here you can see it opens that notebook, and you can see the title of the notebook is unknown or it is showing untitled. Let's change this name by clicking on it and name it numpy and then hit enter. And you can see this is the cell where you can execute the Python command like print hello, and when you execute this you can see it prints hello. And remember, to execute this cell just click on this run button or from your keyboard press shift plus enter. Now to delete this cell, click on this delete button, and now this is the new cell where we can again write the Python code and we can run that Python code. So we have installed the numpy, so let's import that numpy library. To import any file or library in a Python, specify the import keyword and then name of the file or library. So in this case we need to import this numpy framework or library, specify numpy and then from your keyboard press shift plus enter or click on this run button. And after importing, let's verify it. So here specify numpy, then dot, then double underscore version, then again double underscore, and run this cell. You can see we have installed the numpy version 2.1.2. In this section I am going to show you how to create a virtual environment, then set up a Jupyter notebook, and after that how to install numpy on macOS system. So on macOS, open a terminal. Within the terminal, to create a virtual environment, specify here python 3-m v, and after this specify the name of the virtual environment that you want to create. So here I'm going to give name as a DS, which stands for data science, and hit enter. And if you see output like this, which means we have successfully created the DS environment or DS virtual environment. If you are not sure, specify here ls, and it is going to show all the files and folder in the current directory. You can see here this is the DS folder, which means this is the virtual environment that we have created just now. Now to activate this environment, specify command source, then name of the environment that you want to activate. In this case it is a DS, and after this specify slash, then bin, then slash, then activate, and hit enter. And if you see something like this here within the parentheses and environment name as a DS, which means we have activated the virtual environment DS. Now in this environment we can separately install packages or framework, and these packages and framework will be separate from our other computer files and folder. So here let's install the Jupyter notebook. To install the Jupyter notebook, specify command pip install notebook and hit enter. It is going to take some time and install the Jupyter notebook in the DS environment. Now if you see output like this, which means we have successfully installed the Jupyter notebook. Now let's install the numpy. To install the numpy framework or library, specify here pip install numpy and then hit enter. And if you see output like here, successfully installed numpy 2.1.2, that indicate numpy is installed in this DS environment. Now if you want to verify the numpy, specify here pip show numpy and hit enter. Just go up, and here you can see numpy library and version is 2.1.2. Now let's open the Jupyter notebook. To open Jupyter notebook, specify here Jupyter notebook and hit enter. And it opens the Jupyter notebook in your local browser, and here This is the user interface of Jupyter Notebook, and in this Jupyter Notebook we can write our Python code and execute that Python code. So to create the Jupyter Notebook, here you see a new button. Click on this button and click on this Python 3, and then it creates a new file ipynb. Double click on this file and it is going to open that file, and here you can see the name of the file is untitled. So click on this and rename the file name to numpy and then hit enter. After that, you can see here this is the box, and this box is called cell, where we can write our Python code like a print hello, and then we can execute this code. To execute this code we have two methods. In first method we can use this run button, or in the second method we can use the keyboard shortcut where we will press shift plus enter and it is going to execute this Python code in this cell. So you can see in the output it shows hello. So this is how you can install the NumPy on macOS system. We have installed the NumPy. Now next we need to import this NumPy in the current file or in the current environment wherever we want to use it. So to import this NumPy, specify the import keyword and then the name of the library, which is the NumPy, and execute this cell. And when you see here 1, which means we have successfully executed this cell and NumPy is imported. And now you can specify here NumPy, then dot, and access all the function that exist within this NumPy. So here I'm going to access the attribute version, which tells the version of the NumPy. Execute this cell. You can see the version of the NumPy is 2.1.2, and here you can see whenever we want to access any of the function that exist within the NumPy, we need to specify this dot and then the function that exists. We can also give alternate name to this NumPy by specifying as keyword, and after this specify the new name to this NumPy library. So here I am going to give new name as np, and remember you can give any name like kp, ska, and whatever the name that you want to assign, that name will refer to this NumPy library. So here assign np, and now again execute this cell and execute this second cell, and you can see it is still working. But instead of NumPy here, you can specify np and execute this. You can see still it is working. Similarly, you can specify here np, and after np specify the dot and access all the function that exist within this NumPy library. First thing that you need to understand in NumPy is NumPy array. And NumPy arrays are the collection of data type or elements, and these NumPy arrays are the foundation of most numerical computing in Python because they offer efficient ways to store and manipulate large data set. And there are several functions in NumPy that can be used to create a different kind of arrays, but there is a general function that allows us to create an array in NumPy, and that function is the np.array function. Remember np.array function, and this function creates an array object from any iterable such as a list or another array. Now let's see how to use this array function to create a NumPy array. And here I want to mention one thing. If you know about Python list, then you already know about the array. So here to access this array function, just specify np, which is the NumPy library, then dot, then array function like this. And to this function, if you pass the list, that list will be converted into NumPy array. So here I'm going to create a new list, my list, and to this list I will assign a series of number like 1, 2, and 3. And then I'm going to pass this list to this array function like my list, and then I'm going to store the NumPy array into a new variable named array like this. Then next to it I'm going to print array and execute this cell. You can see it creates a NumPy array from the list that you can see in the output. But here I'm sure that you have not confirmed how we can say that it is the NumPy array. To confirm whether it is a NumPy array or not, specify here type function, and if you remember, this type function will tell the type of the object. So here I'm going to specify here object as array and then execute this cell. You can see it shows numpy.end array, which means this array variable or this array object is a NumPy array. Now this array object has a properties or attribute that we can access. For example, we can specify here array object, then dot, and specify here dtype. And this dtype property tells the type of the element within this array. So you can see here this array contains a integer. So if you execute this cell, you can see here it shows int 64, which means each of the element within this array is the integer value that you can see here. So here I'm going to create one more array, and I will call this array2, which is equal to np.array, and then within this parenthesis I can directly pass the list, and here I'm going to use two kinds of element. First is the integer value and second is the float value, like a 25.5, 34.5, like this. And now here I'm going to print array2, and then I'm going to check the data type of this array2. So here I'm going to specify array2 dot dtype and execute this cell, and you can see the data type of the element within this array2 is float 64, which means all the element within this array2 is a float element. But here you can see only two element, such as a 25.5 and 34.5 is a float value, but this first one is the integer value. So what we can do here, we can explicitly specify the data type of the element within this function. Let me show you how we can do that. So here, after specifying the list within the array function, specify the comma, and here specify the keyword argument dtype equal to, and then specify the data type like a string, number, float. So remember, here you can specify valid data type in Python. So we can specify here int, which means all the value within this array will be int. If you execute this, and you can see 23, 25 and 34, and integer means there is no float value. You can see it truncates the 0.5 from these values, and in the result set you can see this is only integer. And if you execute this code again, you can see this time the data type of the element within the array is a int 64. So using this property you can specify the data type of the element within the array. Let's create a string value. So here I'm going to specify names and then equal to, and here I'm going to say James, then Bob, and there is a third name which is a rock, and here I'm going to say array names equal to np.array, and to this array pass the names. And remember, you can also pass this directly to this array function to create an array object. And now here specify print array names. Execute this, and look, it's create an array containing the name of the user. You can also specify here data type explicitly. So right here dtype equal to str, like this. And now execute this, and if you check the data type here like array names dtype, and you can see the dtype is a u5, which is a string. Now you know what is the work of dtype and how to explicitly set the data type of the element within the array. Next attribute is a size attribute. So here specify array object like array names, then dot, and then specify attribute size. And this attribute size tells the total number of the element within the array. And if you execute this line, you can see it shows integer value 3, and this 3 means there are 3 elements within the array object array names, and that you can see here there is a 3 element James, Bob, Rock within this name, and we pass this name to this array function, and this array function create a array object from that list. So remember, this size tells the number of element within the array. Moving next, let's understand what is a multidimensional arrays. In NumPy, you can create a 1D, 2D, 3D array by passing nested list. So here maybe you are thinking, what is a 1D, 2D and 3D? So here 1D means the array with only one dimensional is called 1D array, and the array with a 2 dimensional is called 2D, and the array with a 3 dimension is called 3D arrays. If you are not sure, here we have created array names, and this array name is a 1D array. Also above, we have created this array from this my list. Then here this array is called 1D array. So let's see how to create a 2D array. For example, here I am going to create a 2 list 1, which is equal to series of a number like a 1, 2, 3 and 4, and then I'm going to create a list 2, and it is also going to contain series of number like a 5, 6, 7 and 8. And then here I'm going to create a array 2D, and then call np.array function, and within this function specify the empty square bracket, and within this empty square bracket pass list 1 comma list 2. And now here I'm going to print array 2D. Execute the cell, and you can see this is the 2D NumPy array. And remember, this is the structure of the 2D NumPy array, and this is how it looks. So here we have several attributes that work on the dimension. Here you can check the dimension of this array by specifying the ndim property. Specify here array object, array 2D, then dot, then specify ndim, and execute this cell. You can see it shows integer number 2. This means the dimension of this array 2D is a 2. So that means it is a 2D NumPy array. Remember, this is the syntax to create a 2D NumPy array. You can also directly specify here your list like 1, 2, 3, 4, and then remove this one, specify another list, and say here 5, 6, 7 and 8 like this. And look, first we have specified the empty square bracket, and within that square bracket we have separately specified the 2 list to create a 2D NumPy array. Similarly, you can use here a shape property to know the dimension of the array. So here specify array object array 2D dot shape and execute this. Look, it is showing a tuple which contains element 2 and 4. Here 2 is the row and 4 is the column, which means this array contains 2 rows and 4 columns. If you look at this output, you can see here this one is the first row and this one is the second row. And if you look at the column like 1 5, 2 6, 3 7, 4 8, these are the 4 columns. So this is how you can use the shape property to know the dimension of the array, and use the ndim property to know the number of dimension. Similarly, you can create a 3D array. Let me show you how we can do that. Here specify array 3D and then equal to np.array, and within this array we can directly use the nested list. So here specify empty square bracket, and then within this empty square bracket you can specify 2D array to create a 3D array. So here you can see this is the whole 2D array. So copy this one and paste within this empty square bracket and specify comma. And if you paste the same array again, then this array will become a 3D array. And look at the syntax. We have the empty square bracket, then within this we have specified the first 2D array, then second 2D array separated by comma. and here next to it I'm going to print array 3D. Execute this. You can see this is the structure of the 3D array, and if you want to know the number of dimension, specify here array 3D dot ndim and execute this. Look, it shows the integer 3, which means this array 3D has a 3 dimension. And also if you want to know the shape of this array, specify here array 3D dot shape and execute this. Look, it has a shape of 2 to 4. So this is how you can use the array function in NumPy to create an array object, and you can use the property like a shape, ndim, size and dtype to know the properties of the array. So I hope that you understand how to use the NumPy array function to create an array object. Moving next, let's understand np.zeros function in NumPy. So what is np.zeros function? np.zero function creates an array filled with element as zeros. This means this kind of function allows us to create an array filled entirely with 0. It is useful when you need an empty placeholder array with a specific dimensions, especially in application like initializing weights for the machine learning models, preparing matrices for the computation, or setting up data structures. Let me show you how we can use this to create an array that contains only element as a 0. So here I am going to create a variable zeros array equal to then np dot and call the zeros function. And using this function you can create a 1-dimensional, 2-dimensional, 3-dimensional or multi-dimensional arrays. So if you want to create a 1-dimensional arrays, you just need to provide a integer value. If I will specify here 5, then it is going to create a 1-dimensional arrays containing 1 5 times. Here I am going to print the zeros array, and now execute the cell, and you can see this is the 1-dimensional array, and you can see all the element within the array has a value 0. And if you count the element 1 2 3 4 5, there are 5 elements, because here within the 0 function we have specified the 5 as the number of element, or this represents the shape of the array. If you want to know by using the property size, you can specify here zeros array dot size, execute this, and you can see it shows integer 5, which means this array has a 5 element. You can also find the shape by specifying zeros array dot shape, execute this, and you can see it shows here 5. As you can see in this tuple there is only 1 element, so this is the 1-dimensional array. Similarly, you can find the number of dimension, specify 0 array dot ndim, execute this, you can see it shows 1, which means it has only a 1 dimension. Now you have here created a 1-dimensional array. As you can see here, if you want to create a 2-dimensional array, you need to provide a tuple. Let me show you how we can do that. Here let's create a variable zeros 2D array and then np dot zeros, and within this zeros function, if you want to create a matrix or 2-dimensional array, specify tuple, and here first value is the row and second value is the column. So here the array that I want to keep is going to have 3 rows and 5 columns, and then next to it print zeros 2D array like this, and now execute this. Now look at the structure of the array. Here to the 0 function we have passed the first value as a 3 and the second value as a 5. Here 3 represent the rows of the array and this 5 represent the columns of the array. And if you look here, if you go here horizontally, you can see there are 3 rows and you can see there are 5 columns. This is the first column, this one is the second, third, fourth, and this is the last column. So whenever you want to create a 2D array using 0 function, pass the tuple, and within this tuple you are going to provide a 2 value. First value is the row and the second value is the columns. Next, let's see the shape of this array. So here specify zeros 2D array and then dot shape. Execute this. You can see shape is as a tuple 3 and 5, where 3 represent rows and 5 represent column. Similarly, let's check the dimension here. 2D array dot ndim. Execute this. You can see it shows integer value 2, which means this array 0 2D has a 2 dimension. Similarly, you can find the number of element. Specify here 0 2D array dot size. Execute this. You can see 15, which means this 0 2D array contains 15 elements. Now next, let's see how we can create a 3-dimensional or multi-dimensional array. Let's create a variable zeros 3D. Let's create a variable zeros 3D array equal to np.zeros. And now to create a 3D array, we need to specify 3 values. First value is the layer value, second is the row, and third is the column. So in this case, I want first layer, and then that layer will contain a array, and that array will contain 4 rows and 5 columns. And now here next to it, I'm going to print zeros 3D array. Execute the cell, and you can see here we have a 3D array, and you can see here we have a one layer, and you can see this layer contains a 4 rows. This is the first row, this one is the second, this is the third, and this is the fourth row. And also we have a 5 columns: first column, second column, third column, fourth column, and this is the fifth column. And you can see here 4 rows, 5 column, and then 1 layer. And now you can create a 3D array containing a 2 layers of a different dimensions. For example, you can specify here layer as a 2 and execute the cell. Now you can see here we have a array with 2 layers. This is the first layer and this is the second layer, and this second one also contains a 4 rows and 5 columns. Similarly, if you specify here layer as a 3, now here we have third layer, and third layer is also going to contain a 4 rows 5 columns. And now you can also manipulate the dimension. Let's say here I wanna 2 rows and 4 columns. Execute this. Now you can see this is the first layer, this is the second, and this one is third, and each of these layer contains an array of 2 rows and 4 columns. Now let's check the dimension of the array. 3D array dot ndim. Execute this. We get the error. Here specify zeros, and now execute this. You can see it shows integer value as a 3, which means this 0 3D array has a dimension of 3. Now let's check the size. Specify here zeros 3D array dot size, and now you can see it shows 24, which means this 3D array contains 24 elements. Similarly, let's check the size or shape of this 3D array. Specify here dot shape and execute this. You can see 3 2 4. 3 means there are 3 layers, 2 rows and 4 columns, which means for each layer there are 2 rows and 4 columns that you can see here. Now here let's go up here, and as I told you, it is a empty placeholder array with a specific dimension. So here we have created 1D 2D array with value 0. Now we can fill this value with a different value. For example, here we have created a 2D array. You can see what I can do here. Instead of 0, I can fill the first row with a different value. For example, here I'm going to specify 0 2D array and then square bracket and then 0. So it is going to accept the first row of the 2D array, then equal to, and as you know, this array contains a rows with a 5 element. So here if I specify here 1 2 3 4 5, and next to it I'm going to print zeros 2D array like this. Execute this. Let's fix the name and again execute this, and now you can see the first row contains a different element 1 2 3 4 5. So this is how you can use the zeros function to create an empty placeholder array, and later in your program you can initialize those array with a different value that you can see here. One thing here I want to mention, that you can see the data type of these element within the array is a float. Now to check the data type, specify here zeros 2d array dot dtype and execute this. Look, dtype is float 64. In the zeros function, you can specify the dtype parameter to specify the data type of the element. For example, here I'm going to specify array equal to np.zeros, and here I'm going to create a 1D array, and this array will contain 4 elements. And after this, specify the dtype parameter equal to int, and then execute this. And when you print the array, you get all the element in integer form. So look, the dot disappeared. You can see here within this array 1 dot 2 dot. This dot indicate that this is the float value, but here you can't see that dot, which means it is an integer. If you have another kind of data, you can specify that data type here. So this is all about a zeros function in NumPy to create a array filled with a zeros values. Next function in NumPy to create array is a np.one, and this function creates an array filled entirely with a value 1 or ones, and this function is similar to a np.zeros. You can see here above, this np.zeros function create an array containing an element as 0, but this np.ones create an array containing element as 1. It can be used to initialize arrays of different shape and data types, and this function is useful when you need an array of a specific shape with a default value of 1, often as a placeholder. Now let's see how to use this function. So here first I'm going to create a 1D array using this np.ones. So here create a variable array 1D equal to then np.ones, and within this you can specify a integer. Here I'm going to specify integer 4. So what it does, it is going to create array containing a 4 element as 1, and next to it I'm going to print array 1D. Now execute the cell. You can see this is the one-dimensional array, and you can see all the element within this array is a 1. Okay, next let's check the dimension of this array. Here specify array 1D dot ndim. Now execute this. It shows 1, which means it has a dimension of 1. Now let's check the size, array 1D dot size, and now you can see it shows 4, which means this array contains 4 elements. Let's also check the shape of this array. Specify here array 1D dot shape, and look, it shows only first element within the tuple, which is 4. So the shape of this array is 4. Now let's check the type of the element within this array. Specify here array 1D dot dtype and execute this. You can see the data type of the element within this array is a float. So here what you can do, you can also specify comma then dtype to specify the data type of the element within this array. Here you can see if you specify int, then it is going to remove this dot. So let's execute this, and now execute all this code. You can see here now this contain integer value of 1. Now let's create a 2-dimensional array with a value of 1. So here create a variable 2D equal to np.ones. Then here as a tuple specify rows and column of the 2-dimensional array. Here this array will contain a 3 rows and 4 columns. Next to it print the array 2D like this. Now execute the cell. You can see this is the 2D array, and all the element within the array is 1. You can see. Now let's check the dimension of this array. Specify here array 2D dot ndim. Execute this. You can see dimension is 2. Let's check the size, array 2D dot size. You can see it is 12, which means this array contains 12 elements. Let's also check the shape, array 2D dot shape.
shape, execute this. You can see shape is a 3 and 4. And also let's check the data type of the element within this array. Specify here array 2d.dtype and execute this. You can see the data type of each element within the array is float. You can change the data type to integer by specifying the dtype parameter equal to int like this. Now execute this. You can see now all the element within this array is integer. If you execute this code, you can see now it is showing int 64. Similarly, you can create a 3-dimensional array. Specify here array 3d equal to np.ones, and here within this you can specify 3 values. First is the layer of the 3-dimensional array, so it is going to contain 2 layers. Then number of rows, it is going to contain 3 rows, and then number of column, it is going to contain 5 columns. And next to it, print array 3d, and now execute this. You can see this is the first layer and this is the second layer. Each layer contains 3 rows and 5 columns. Similarly, if you want to increase the layer, just specify here 4. It is going to create a 3-dimensional array with 4 layers. Execute this. Count 1, 2, 3 and 4. It contains 4 layers and each layer contains 3 rows and 5 columns. Let's check the dimension here. Specify here array 3d.ndim. Execute this. It is showing 3, which means this array has a dimension of 3. Similarly, let's check the element. Specify here 3d.size. You can see it is showing 60, which means this array contains 60 elements. Let's check the data type of the array. Array 3d.dtype. Execute this. You can see float 64. If you want to change it to integer, just here specify comma, then specify dtype parameter equal to int. Execute this, and now you can see all the element within the array is integer. Let's check the dtype again. You can see it's showing int 64, which means all the one within the array is a integer. So this is how you can use the np.ones to create a array containing a default value of 1. Moving next, we have another function in NumPy to create array is called np.i, and this function in NumPy creates a 2D array or a matrix with ones on the main diagonal and zeros everywhere else. This type of matrix is known as an identity matrix, and it is widely used in the linear algebra because they act as the multiplicative identity in matrix multiplication, which means any matrix multiplied by any identity matrix remains unchanged. Let's see how to use this np.i. So here I'm going to create a identity matrix. I will say identity matrix equal to np.i, and now here this identity matrix takes a 2 important parameter, which is a n or m, where n represent the rows and m represent the column. So here I'm going to create a matrix or a 2D array with a 3 rows and 4 columns. And now next to it, print identity matrix like this and execute the cell. Look, all the element at the main diagonal is a 1 and element above the diagonal or below the diagonal are zeros. So you can see here the definition of the np.i is it creates a 2D matrix with a ones on the main diagonal and zeros everywhere else. You can see on the main diagonal we have all the value as a 1 and value above or below to diagonal is a 0. You can also move this diagonal above and below by specifying the k parameter within this I. For example, here I am going to create another matrix and I will call it matrix I equal to then np.i, and within this I am going to create a square matrix 4 by 4, or you can say it is going to contain 4 rows and 4 columns. And after this I am going to specify parameter k, which stands for diagonal, and by default this parameter has a value of 0. And now if you specify a positive value, it is going to move the diagonal above, and if you specify negative value, then it is going to move the diagonal below. So I'm going to keep the by default value, and after that we will change the k value and see how it is working. So here print matrix I, and now execute this, and look, all the element at the diagonal is 1, and the element above the diagonal is 0, and below the diagonal is 0. So here let's change the value 1, and this is going to move the diagonal one step above. So here execute this, and now you can see this is the diagonal, and the value of all the diagonal is 1. Similarly, if you specify here 2, it is going to move the diagonal up. Now you can see this is the diagonal that contains a 1 as a value, and if you specify here -1, then it is going to move the diagonal below. So execute this, and now you can see this is the diagonal with the value 1, and now specify here -2 again, and now it moves down the diagonal again, and you can see the value of the diagonal is 1. So this is how you can use this npi to create an identity matrix, and this matrix contains a value as a 1 on the main diagonal and 0 everywhere else. If you want to check the size of the matrix, you can specify here matrix I dot size, execute this, you can see it is showing 16, which means it contains a 16 element. Similarly, you can check the dimension, specify here dot ndim, and now you can see 2, which means this array has a 2 dimension. Similarly, you can check the shape, specify here matrix I dot shape, execute this, you can see shape is 4 and 4. Also, you can check the data type of the element within this identity matrix by specifying dtype, and you can see the data type of the element is a by default float. You can specify here dtype by specifying dtype parameter equal to int, then it is going to insert all the integer value on the diagonal. Let's execute this. You can see it inserts a integer value of 1 at the diagonal. Now let's check the data type again. You can see this time element of the data type is a int64. So this is all about np.i function, and this function is very useful in a linear algebra because it allows us to perform operations like finding matrix inverse and eigenvalue. Even you can use this in a machine learning and neural network for defining identity mapping or scaling layers. Next function in NumPy is np.full, and this function in NumPy creates an array filled with a specified value which can be any number you choose. And this function is similar to np.zeros and np.ones, but it gives you more control by allowing you to define any initial value for each element in the array. So you have used the np.zeros and np.one, which creates an array containing only a 0 or 1 value. But here you can specify your own value while creating arrays. For example, here I'm going to define a array name full array, which is equal to np.full. And here first you need to specify the shape of the array. So here I will specify a integer value 4, and this np.full will create a one-dimensional array. And also we need to specify the value the array will contain. So here the array will contain the value 6. And now next to it I am going to print full array. Execute this. You can see this is the one-dimensional array, and this array contains 4 elements as a 6. So here 4 represents the shape of the array and 6 is the value that you want to include within this array. But in case of zeros, the array only contains a 0 value, or in case of ones, the array only contains element as a 1. Here you can specify your own values that you want to include in the array. For example, if you want to include 8, just specify 8. It is going to create a one-dimensional array containing a 8 elements. Now here you can also create a two-dimensional array. For example, full 2D array equal to np.full, and then as a tuple, this array will contain 3 rows and 4 columns, and the value will be 2. Next to it, print full 2D array like this, execute the cell, and now you can see this is the two-dimensional array containing only element as a 2. If you want to check the dimension, specify here full 2D array dot ndim. Execute this, you can see it shows 2, which means this array has a 2 dimension. Also, if you want to check all the element, specify here full 2D array dot size, and now you can see it shows 12, which means this array contains 12 elements. So this is how you can use this full function to create a 1D, 2D or 3D array with a specific value or the value that you want to include. Here you can also specify the data type of the element. For example, you can see all the data type within this array is a integer. If you are not sure, specify here full 2D array dot dtype and execute this. Look, it shows integer. If you want to change it to different data type, just here specify the parameter dtype equal to float and execute this. And now here, if you execute this line, you can see this time it shows float 64, which means this array contains float values. Similarly, you can create a 3D array. So here I'm going to create a full 3D array equal to np.full. Then, as you know, you need to specify 3 value within this parenthesis as a tuple. First is layer, so this array is going to contain 4 layers, and each layer will contain 2 rows and 3 columns, and the value will be 9. Next to it, print full 3D array and execute this. You can see this is the first layer, this one is the second, this one is the third, and this one is the 4, and each layer you can see contains a 2 rows and 3 columns with a value of 9. If you are not sure, specify here full 3D array dot ndim. You can see dimension is 3. If you want to check the size of the array, 3D array dot size, you can see 24, which means this array contains 24 elements. And want to check the data type of the array, specify here full 3D array dtype. You can see the dtype is int64. You can change the data type by specifying here dtype parameter as a float, and it is going to convert all the element within the array as a float. You can see here. So this is how you can use the np.full function to create your own array with a different shape and specified value. Moving next, we have another function in NumPy called np.arange, and this function in NumPy creates an array with a evenly spaced values within a given interval. It is similar to Python built-in range function, but it returns array instead of a list and allows floating point values as well as integers. np.arange function is often used for generating a sequence of numbers, which can be particularly useful for indexing, creating a time interval, or generating a test data. So here, this is the syntax of np.arange. As you can see, it accepts parameter start, stop, step, and data type, which is a dtype. And remember, stop is a exclusive, or the stop value is not included in the array. Let me show you how we can use this np.arange. Remember, this np.arange generate a sequence of numbers. So here, for example, I'm going to create a variable array, and this variable is going to contain an array created by arange. So specify here np.arange. And now, if you provide a single integer value like 5, then this value is considered as a stop value. And when you execute this line, it is going to create a values from 0 to 4. For example, here print array, and now execute this. You can see It creates a one-dimensional arrays containing 5 values. You can see values start from 0 and end at the 4, and here you can see the value 5 is not included in this array. As you can see in the definition, where stop is exclusive, which means stop value is not included in the array. So let's specify the start value. So here I'm going to create a array 1 equal to np.arange, and here I'm going to specify start value as a 5 and end value as a 10. And now next to it I'm going to print array 1. Execute this, and now this time you can see it creates a array and the value start from the 5 and end at the 9th, but 10 is not included in the array. So you can control the values of the array like starting or ending point. Similarly, you can use this step parameter to specify the interval between the values. For example, here I'm going to create array 3, which is equal to np.arange, and then the starting value will be 0, ending value will be 10, and the interval between each value will be 2. And remember, this third value is the step value, which defines the interval between values in the sequence. So here print array 3, execute this, and now you can see this array contain values which start from 0, then you can see interval of 2, then it includes the 2 value, then 4, 6, 8, and you can see here interval between values in the sequence is a 2. You can specify another step here or interval like a 4 and execute this. Look, this time it only contains a 3 values 0, 4, 8, and interval between values in the sequence is 4. You can see here. Similarly, you can create arrays with a floating point number using the arrange function. For example, specify here array 4 equal to np.arange, and then specify starting value 0 and ending value at 1, and then step is like a 0.2, which means the interval value between the sequence will be 0.2. Now next to it print array 4, execute this. You can see 0, 0.2, 0.4, 0.6 and 0.8. So this is how you can create a arrays with a floating point number. Also, you can specify the data type. For example, here I'm going to create array 5, which is equal to np.arange, and then the value will start from 2 and end at 20, and the step will be 3, and after this specify dtype parameter to specify the data type of the element. So here in this case I'm going to assign a float, and then next to it print array 5, execute the cell. You can see it generate a sequence of number which start from 2 and end at 17. You can see all this number has a data type of float. You can also use or access all the properties that we have learned previous. For example, you can specify array 5 dot size and execute this. You can see it shows 6. Similarly, array 5 dot ndim, execute this, it is a 1. Next, we have another function in NumPy to create array is called np.linspace, and this function generates an array of evenly spaced number over a specified interval. So this linspace uses a specific step size to generate a defined number of points between a 2 value, and that value is a start and a stop value. And this is useful when you want a fixed number of samples between 2 values, especially for continuous data. Let me show you how we can use this lin function to generate array. So here I'm going to create a array and I will give name array 1 again, and then I'm gonna use here np.linspace function. And then within this function, first you need to provide 2 values. First value is the start value and the second is the stop. So here the value will start from 0 and will end at 10 or stop at 10. And when you execute this line of code, it is going to generate a sample of numbers, and that number will be stored in this array1 variable. So next to it, I'm going to print array1 like this, and now execute the cell. As you can see, it generates a array of evenly spaced number. By default, it generates a 50 points. If you count from here, this is the first point, this one is the second point, and so on. It generates a 50 points. As you can see, the number 10 is included in the array because here by default this 10 is a inclusive, which means in the array this 10 will be included. But how you can control the number of points that you generate here? So this np.linspace function takes one more parameter, and that parameter is a num parameter, and this num parameter will take an integer, or it takes a number which represents the number of sample or number of point you want to generate. Suppose I want to generate 5 point between 0 and 10. Let's execute this and see. Execute the cell, and now you can see we have a 5 number. This is the first, this one is the second, third, and this one is the fourth, and this is the last one, which is the fifth value. So you can control the number of point that you want to generate between two values. Now here maybe you are confused what is the step size or how this number is calculated. Like you can see here it is 0, then we have a 2.5, then the third number is a 5, and then the fourth number is 7.5, and how this number is calculated. So by default this len function use the step size to determine the next number. If you want to know what is the current step size to generate this number, you are going to make it true one of the parameter which accept this linspace, and that parameter is a return step, and you need to make this parameter true like this. And now when you execute again this, you can see here we have another number which is a 2.5, which means if you calculate the difference between each number, you will find the difference is a 2.5. For example, here you can see we have the first number is a 0, and when we add 2.5 this number, we get 2.5. So this is the second number, and when we add 2.5 to this 2.5, we get a 5. So here you can see we have the 5, and again when you add 2.5 to 5, you get a 7.5. So we have the fourth number 7.5, and lastly when we add 2.5 to 7.5, we get a 10. So we get a 5 numbers or 5 continuous data with step size of 2.5. And you can know the step size of each sample which is generated using this linspace by specifying return step equal to true. Also you can control the number of sample you want to generate. For example, here I'm going to create another array 2 which is equal to np.linspace, and then I want to start the number from 5 and then it stop at 20, and I want to generate a number of point or number of continuous data 10, and then I want to also know the step size between each number, so make this one true. And next to it print array 2 and execute this, and now you can see we have one dimensional array containing a 10 continuous data or 10 sample points, and you can see the step size between each of the number is a 1.66 something. So this is how you can use this linspace to generate a evenly spaced number over a specified interval. Here a specified interval means we are generating number between start or stop values. Okay, next let's apply all the attribute like size, ndim and shape. So for the moment I'm going to remove this return step parameter, and again I'm going to execute this, and now here I'm going to know the size of the array. So specify here array2 dot size, execute this. Look, it returns 10, which means this array contain a 10 values. Similarly specify here array2 dot shape and execute this. Here we have tuple, and in this tuple we have only one value which is 10, which means this array has a one dimension. Or if you want to know the dimension, you can specify here ndim and execute this. Look, it returns 1, which means it has a dimension of 1. So this is all the property that we can also apply on the array generated using the linspace. And remember, you can apply all this property, all the function that we have learned till now. Now here you can see we have generated a sample or continuous data, but here you can see this continuous data is a float. What happens if you want to generate a sample of integers? So for that you need to specify the data type for the each of the data within the array. And here I'm going to create another array3 equal to np.linspace, and then I'm going to generate number from 0 to 15, and then the number of the data point will be 10, and then you can use the parameter dtype to specify the data type. So in this case I'm going to generate a 10 integer value, so I will specify dtype as a int, and next to it print array3 and execute this, and look, it generate a number from 0 to 15, and all this number or all this data is a integer data. This is how we can use this lin function to generate an array of data. Moving next, we have a module in a NumPy called random module, and this module provides a various function to generate a random numbers, arrays, samples from a different distribution. And this is essential in data science, machine learning, and any applications that require randomness sampling. Let's explore some of the functions from this module. Now here, first I'm going to create a variable rand array, and this variable is going to contain an array containing a random values. Then here access the np.random module like this, and after this specify dot, and now you can access all the function within this module. So first function is a rand function, and this function takes the shape of the array and returns the random values as an array, and these values are from the uniform distribution between 0 and 1 value. So here if you specify integer 4, then it is going to generate a 4 values from a uniform distribution between 0 and 1 value. Next to it I'm going to print rand array like this, and now execute the cell, and look, it returns one dimension array containing a random 4 values, and this value is generated from uniform distribution between 0 and 1. Now let's change this 4 to 10 and execute the cell again, and look, now it creates another array containing a 10 random values, and here you can see the dimension of the array is a 1. If you are not sure, specify here rand array.ndim and execute this. Now you can see it shows 1. Now if you want to change the dimension of the array, here you can specify dimension like a 2 3, which means this array is going to have 2 rows and 3 columns, and this array will contain a random values between 0 and 1. And if you again execute this, and now you can see this is the 2-dimensional array containing a different random values. If you execute this line, and you can see this time it shows 2, which means this array has a 2 dimension. So using this rand function, you can generate a random values in a given shape from a uniform distribution between 0 and 1. And now the next function is the random n function. So let me write here random n array equal to np.random.randn, and here you can see this n represent a standard normal distribution. If you are coming from statistics or you know about distribution in statistics, then there is a distribution called standard normal distribution with mean 0 and standard deviation equal to 1. So it generates a random values from standard normal distribution. So if you specify here 3, then it is going to generate a 1-dimensional array, and that array will contain a values from standard normal distribution. Let's print here rand n array and execute this line, and now you can see this is the 1-dimensional array containing a 3 random values from the standard normal distribution. Similarly, if you want to generate a 2-dimensional, you can specify here 3 and 4. then it is going to generate array with a 3 rows and 4 column. Now execute these lines and you can see this array contains a random values from a standard normal distribution. And if you want to know the dimension, specify here randn array.ndim, execute this. Look, dimension is 2. And remember, you can create a 3-dimensional or multi-dimensional arrays containing a random values. So here, for example, I am just showing you 1 or 2 dimension. Similarly, this np.random provides another function randint, which generates a random integer from discrete uniform distribution within a specified range. For example, randint array, and here np.random, then that function randint. And now here you need to provide 2 values. First is the low value, or called lowest integer, so which is a 0, and then second is the highest integer, and here highest integer is 10. You can think it is like a start or a stop value. And after that you can provide the size, and which is the shape or the dimension of the array. So you can provide a dimension or size as a tuple. So here I'm going to specify 2 2, which means this array is going to have 2 rows and 2 columns. And now next to it, print randint array like this, execute the cell. Now you can see we have 2-dimensional array containing a random values between 0 and 10. And if you are not sure, you can check the dimension randint array dot ndim, execute this. Look, it shows 2, which means this array has a 2 dimension. You can specify here dimension you want. Suppose you want to create a 3-dimension array containing a random values between 0 and 10. You can specify here third value, you can say here 2. Now execute this, and look, this array contains 2 layers, and each layer has a 2 rows and 2 columns. And you can see both the layer contains a random values between 0 and 10. And if you execute this line, you can see this time it shows 3, which means this array has a 3 dimension. So whenever you want to generate an array containing a random integer value, then use this randint function from this np.random module. And this np.random module contain a bunch of functions to generate a random numbers. For example, it contains a random.choice, it contains a random.uniform, it contains a random.normal to generate a random values from different distribution. So for example, here I have shown a few of the functions from this np.random module. If you want to know more about this, then you must visit the Numpy docs or Numpy documentation. So this is all about a array in Numpy, and you learn about bunch of function that allows you to create a array in Numpy. In this section, we are going to learn about Numpy functions, and this function you will use in your machine learning or data science journey. So we will explore this function one by one, and these are the most essential function. Now the first function is the np.reshape function, and this reshape function allows you to change the shape or the dimension of any array without altering its data. And this function has a rule that you need to know, and the rule is a total number of element in the original array must match the number of element in the new shape. So you can change the dimension of a array from 1D to 2D or 2D to 3D, but while changing, the element must be same. So if the element in the original arrays varies from the element that you want into the new dimension, then it is going to raise error, and you will understand this soon. So here I'm going to take an example, and in this example I'm going to create a array variable, and this is equal to np.array, and as you know, this function will create a array of a specified element. So here I'm going to create a 1-dimensional array, specify square bracket, and within this I'm going to include a series of number 1, 2, 3, 4, 5 and 6, and next to it I'm going to print array like this. And now we get the error because first we need to import this Numpy module So here above specify import numpy as np, and now again execute this and we get the one-dimensional array. Now here our aim is to reshape or change the dimension of array. So first let's check the dimension of this array. Here specify array.ndim and execute this. Look, it shows 1, which means this array has a 1 dimension. Also let's check the shape. So here specify array.shape and execute this. Look, here we have a tuple, and within tuple we have only one element 6, which means it has a 1 dimension. If you have any confusion about this tuple, how we determine whether it is a 1D or 2D, if you remember from previous tutorial, when we specify the shape, we specify parentheses, and within this parentheses we specify row as a 2 and column as a 3. So this means the 2D array is going to contain 2 rows and 3 columns. And here you can see there is only one value, which is the row in this case, so it is the 1 dimension. If you are going to have a 2D, then it is going to also contain the columns. Now here we want to convert this array into a 2D array, or we can say in 2-dimensional array. So here to convert this array into 2-dimensional array, I'm going to create another array 2, and then this array is going to store 2-dimensional array. So here call the function reshape. So specify here np.reshape, and then to this function we need to provide 2 values. First value is the array that we want to convert, and the second value is the shape or the dimension in which we want to convert. So here the first one is the array, and this is the array we want to convert into 2 dimension. And after this specify comma, and then here specify tuple, and within this tuple we want to specify rows and column. Within this tuple specify parentheses, and as you know, in this parentheses, to create 2D array you need to specify rows and column. So here I'm going to specify row as 2 and column as 3. And remember, if you multiply these rows with column you get 6, which means this array is going to contain 6 elements. And now next to it I'm going to print array 2 and execute the cell, and look, we get this 2D array. So you can see all the element within this array is similar with all the element within this original array, and this is the 1D array and this is the 2D array, and this 2D array is created from this 1D array you can see here. So to this reshape function you need to pass a 2 value. First is the array whose dimension you want to convert into another dimension. Second is the shape of the new array. And now here you can see there is a rule: the total number of elements in the original array must match the total number of elements in the new shape. And let me show you what it means. So here I'm going to create another array. I will call it array data equal to np.array, and then within this I'm going to include a 8 element 1 2 3 4 5 6 7 and 8. And now I'm going to print array data and execute this, and now you can see this is the 1-dimensional array. Sorry for the mistake, here specify comma, and now again execute this, and now you can see this array contains 8 elements, and this is the 1-dimensional array. And now you want to convert this 1-dimensional array into 2-dimension. First you need to count the number of elements within this array. You can see there are 8 elements, and if you are not sure you can specify here array data and call the property size, and this size property shows the number of elements within the array, and you can see it shows it is 8. And now to convert this 1D array into 2D, here I am going to create array data 2 equal to np.reshape, and then pass the array that you want to convert into 2D. So in this case AR data. And now here after this you need to specify the shape or dimension of new array. So in this case specify here 2 into 3 again. And as you know, when you multiply 2 with 3 then you get a 6, which means this array is going to contain 6 elements. And now next to it I'm going to print array data 2 and execute this. We get the error. Now look at the error, and this error is the value error, and it is saying cannot reshape array of size 8 into shape 2 3, which means this original array you can see here contains a total number of 8 element, but here the new shape of the array is a 2 3. When you multiply 2 into 3 you get 6, which means this new shape array is going to contain 6 element, but here in the original we have 8 elements. So this is not possible. So we need to convert this shape, or we need to change this shape so that the new array can contain all the 8 elements that exist within this array data. So here instead of 3, if you specify 4, when you multiply 2 into 4 you get 8, which means this new array is going to contain 8 elements. So let's execute this, and now this time it is working, and you can see this 2-dimensional array containing total 8 elements, and this all 8 element is coming from this original array data. And you can also change the column to row. So here instead of 2 specify 4, or instead of 4 here specify 2, and if you again multiply you get 8. And now execute this, you get 2-dimensional array, but this time you can see number of rows are 4 and columns are 2. So this is how you can use this reshape function to reshape any array into a specified or in your desired dimension. But remember, the number of element in the original array must match the total number of element in the new shape. And I hope that you understand how to define this new dimension shape for this array. Now moving next, let's see how to create a 3-dimensional array, because here you can see in the tuple we have only 2 element, or these 2 elements are rows and columns, so it is 2D. But in case of 3D you learn there are layers, and each layer contains a same or equal amount of element in the array. So here I'm going to create another variable array, and I will call it data3, and this array is going to contain a 3D array. So here call np.reshape, and then here I'm going to take the same array data and I will convert this array data into 3D. So specify here array data, and after this specify parentheses, or here in case of 3D it accepts a 3 parameter. So here first is the layer, so in this case we want a 2 layer, and then after this you need to specify rows and column. So this new 3D array is going to contain 2 rows and 2 column, and if you multiply all these you can get 8. So how you get 8? Multiply 2 into 2 you get 4, and when you multiply 4 with 2 you get 8. So that means the new array is going to contain 8 elements. And as you can see, in the old array or in the original array or in this 1-dimensional array we have only 8 elements. So it is following rule. This means this is going to work. Now next to it I'm going to print array data3 and execute this, and look here we have 2 layers, because in the first parameter, or we have provided first value as 2, and then you can see each of the array contains 2 rows and 2 columns. So here let's check the dimension of this array. Specify here array data3 dot ndim. Execute this, you can see it shows 3, which means this array has a 3 dimension. Let's also check the number of element, array data3 dot size, and execute this. You can see it shows 8, which means this array has 8 element. So here this is how you can use the reshape function to reshape or change the dimension of existing array into a different dimension or different shape. So while changing the shape, you must remember the new shape must compatible with the total size of the original array. Next function in NumPy is called np.max function, and this function returns the maximum value from the array. If you have array and you want to find the greatest or maximum value in the array, whether array is 1D, 2D or 3D, then you can use this function. Let me show you how we can do that. So here I'm going to create a array value variable, and this array value variable will contain a random array value. So here use np.random.randint, and here starting value is a 0 and ending value is a 20. And then I want to generate a 15 values, which means array will contain 15 continuous data. And next to it print array value like this, execute the cell, and look, here we have a one-dimensional array containing a random values between 0 to 20. And now if you want to find the maximum value in this array, you just need to specify here np.max function. And to this function, you need to pass the whole array that contains the maximum value. So in this case, it is an array value. And now when you execute the cell, you can see it returns 18. You can see here within this one-dimensional array, we have the maximum value, and the maximum value is 18. Similarly, you can find the maximum value in 2D array. If you look at the dimension of this array, specify here array, then value, then dot ndim, execute this, it shows 1, which means this array has a 1 dimension. Now let's find the maximum value in 2 dimension. So here I'm going to create a array value 1 equal to np.random, then randint, and this time generate values from 10 to 20. Now after this, you need to specify the shape of the array. So in this case it is a 2D, so specify parentheses, it must be 4 into 5. And now next to it, print array value 1 and execute this. Here we have a 2-dimensional array. If you are not sure, specify here array value 1 dot ndim, execute this. Look, it is 2, which means it has a 2 dimension. Now if you want to find the maximum value in this 2-dimensional array, just specify here np.max, then pass the 2D array. So here array value 1, and now execute this. You can see maximum value in this array is a 19. So here you can see it finds the maximum value in the array, and that maximum value is 19. What happens you want to find the maximum value according to rows or column? For that, this max function accepts another parameter called axis. Let me show you. So here you can see when we move horizontally like this, then it is a row, and when we move vertically, then it is a column. So here if you specify axis equal to 0, which means it is going to find all the maximum value in each column. If you execute this, you can see you get the array, and look, 19, 16, 18, 17, 16 is the max value in each column. If you are not sure, look vertically, you can see here 19 is the greatest value in this column. Then here we have 16, it is the greatest value in this column or in the second column. Similarly, here we have 18, and this 18 is the maximum value in the third column, and so on for the other maximum value. Similarly, if you want to find the maximum value according to row, just specify here 1, and this here 1 means find all the maximum value in the row. When you execute the cell, now here we have 17, 18, 18 and 19. Now if you go row wise, you can see in this row we have 17, which is the maximum value. Then in the second row you can see we have 18, this is the maximum value in the row. Similarly, in the row third we have again 18, and this is the maximum value in this row. And lastly, in this last row we have the maximum value, and the maximum value is the 19. This is how you can use the max function to find the maximum value within a 1D, 2D or along the axis in the array. Moving next, we have another function called argument max function, and this function is similar to max function, but it returns the index of the maximum value in the array. So here max function returns the maximum value, and this argument max only returns the index of the maximum value in the array. Let me show you. If you remember, we created array value, so print array value. You can see this is a one-dimensional array value, and you can check all the element in this array by specifying array value dot size, and you can see it contains 15 element. Now here look at this first element within the array, and this element has index 0, and the second element has index 1, third element has index 2, fourth element has index 3, and so on for all the elements within the array. If you want to access the first element, you just need to specify here array name, which is the array value, then square bracket, and within square bracket specify 0, and this represent the first element. If you execute this, now you get 9, and as you can see this 9 is integer, so here it is written int 32. So if you want to access the second element, specify here 1, and now you can see you get the second element, which is 4. So using the index you can access all the element. So if you want to know the index of the maximum value in this array, here you need to specify np.argmax, then pass the array, which is the array value. Execute this, and now you can see the index of the maximum value in the array is 6. So if you look at this array from here, just count 0, 1, 2, 3, 4, 5 and 6. You can see 18 is the maximum in this array, so it returns the index of that element. Similarly, you can find the index of the maximum value in the 2D array. So if you remember, we created another 2D array called array value 1, and now if you want to find the index of the maximum value, just specify here np.argmax, and then specify array value 1 like this. Execute this. You can see the index of the maximum value is 15 in this 2D array. If you want to find index of the each maximum value along the column, just specify here x is equal to 0 and execute this. Similarly, if you want to find the index of the maximum value on each rows, just specify here 1, and it is going to return index of the each maximum value in each rows. This is how you can use the argument max to find the index of the maximum value in the array. Next, we have another function in NumPy called np.min, and this function returns the minimum value of the array. So for example, first let's print the array value, and as you know, this array is a one-dimensional array. So in Jupyter Notebook, you can print the array value without using the print function. You can see here, you can directly specify the variable here and execute the cell. It is going to print all the values of that variable. And now if you want to find the minimum value of this array, just specify here np.min, and then to this function pass the array value. Execute this. Look, it shows minimum value is the 0 value. This is how you can use this min function to find the minimum value in the one dimension. Let's check with a 2 dimension. So here we have another array which is a 2 dimension, and to find the minimum value in this 2-dimensional array, specify here np.min, then specify array with a 2 dimension, which is the array value 1, and execute this. So in this 2-dimensional array we have minimum value which is the 11. So this is how you can use this min function, and min function is similar to the max function, only it returns the, you can also specify the axis here. Axis 0 means find all the minimum value along the each column. Execute this, and now you get the array and which contains all the minimum value along each of the column. Similarly, if you want to find all the minimum value along each of the rows, specify 1 and execute this. You get all the minimum value along each rows in the array. Moving next, we have another function called argument min function, and this function returns the index of the minimum value within the array. And as you know, this one is similar to argument max, but it returns the index of the minimum value. So here first let's print the array value, and you can see this is the one-dimensional array. To find the index of the minimum value, specify here np.argument_min and pass the array. So here it is array value. Now execute this. As you can see, the index of the minimum value is 7. Similarly, you can find the index of minimum value within 2D or 3D array. So first print the 2D array, which is the array value 1, and now in this, to find the index of minimum value, specify here np.argument argument min, then to this array pass the two-dimensional array which is the array value 1. Execute this, and now it returns 10, which means index of the minimum value is 10. You can also specify here x is equal to 0, which represents the column, which means it is going to return the index of the minimum value in each column. Execute this, and now we have index of each minimum value in the column. Similarly, you can find index of each minimum value within a rows by specifying 1 here. Execute this. Now we get all the index of a minimum value in each rows. This is how you can use the argument min function to find the index of minimum value within the array. Next, we have another function in NumPy is called np.concatenate function, and you can use this function to join 2 or more arrays along specified axes, and it is helpful when you want to combine arrays into a single array without modifying the data. Let's see how to use this concatenate function. Here I am going to create a 2 array. This is the first array, and then np.arange, and it is going to generate array from 1 to 7. Similarly, I am going to create another array 2, and it is also going to contain a number from 7 to 14. And next to it, I am going to print array, then again going to print array 2. Execute this. Now here we have the array. Let's combine both the array into a single array. So here I am going to create array 3, and this array 3 is going to store the array 1 and array 2. So here specify np, then dot, then concatenate function, and within function specify square bracket, and here pass the array 1 and then array 2. And this concatenate function combines both the array into a single array called array 3, you can see here. So next to it, print array 3. Now execute the cell. You can see here we have array, and this array is a combination of array 1 and array 2. So this is how you can use the concatenate function to combine one-dimensional arrays into a single one-dimensional array. Next, let's combine more than one-dimensional arrays into a single array. So here I'm going to create another variable array 4, and which is equal to np.random.randint, and as you know, this function generates an array containing a random integer value. So here start value is 1 and then int value is 10, and here it is a two-dimensional, so the shape will be 2 rows and 4 columns, which means this line will generate array containing a 2 rows and 4 columns, and those rows and column will contain a value between 1 and 10. Next, create another variable array 5, which is equal to np.random.randint, and then it is going to generate a value from 10, then int at 20, and also shape is a 2 rows and 4 columns. Next to it, print array 4, and then again also print the array 5. Execute this, and now here we have 2 arrays of 2 dimension, and these array contains a random values. Now let's combine these array into a single array. So here I'm going to create another array 6, which is equal to np dot, then call the concatenate function, and within this function specify both the array. To specify both the array, specify square bracket, and within this specify array 4 and then array 5. And now next to it, print array 6 like this. Execute the cell, and now here we have the new array, which is a combination of array 4 and array 5. So this is how you can use this concatenate function to combine or to join 2 or more arrays along a specified axis. Let's concatenate arrays or join arrays according to the axis, and as you know, when x is equal to 0, which means it is going to join the array according to row, and when x is equal to 1, then it is going to join the array according to column. Let's see with an example. Here I'm going to create an array data equal to and then np dot call the array function. If you remember, then let's create a two-dimensional array. So to create a two-dimensional array, specify square bracket, and within this specify first array, which is 1 and 2, then comma, then specify second array, which is a 3 and 4. Similarly, create a array data 2 and then equal to np dot array, and also this is going to be a two-dimensional array. So specify square bracket, and within this specify 5 and 6, and after this comma, then again array, and this one is the 7 and 8. Next to it, print array data and also print the array data 2. Execute the cell, and now here we have the arrays. Now we want to combine this array into a single array along the axis, such as a row and column. So here create another variable result, and which is equal to np.concatenate, and then specify the tuple here like this, and here specify both the arrays that you want to combine. So here first one is the array data, then comma, second one is the array data 2, and after this specify comma, then axis, then equal to 0. And as you know, when we specify x is equal to 0, which means it is going to combine the array according to rows. Now next to it, print result and execute this, and now look at the result. If you closely look at the result, you will see when the axis is equal to 0, then the arrays are joined row wise. The two arrays, array data and array data 2, are stacked on top of each other, that you can see here. Similarly, you can combine the arrays according to the column. Let me show you. Here specify np.concatenate, and then within this specify array. This is the first array, then specify second array, array data 2, and now here specify comma, then specify axis equal to 1. Next to it, print result, and now when you execute the cell, you can see here arrays are joined side by side. So this is how you can use the axis to combine the arrays according to row wise, according to column wise. I hope that you understand how to use concatenate function to combine, to add two or more arrays into a single arrays. Moving next, we have another function in NumPy called np.split function, and this function is used to split an array into multiple sub-arrays, and you can specify the number of sub-arrays or provide a specific indices where the split should occur. It is useful when you want to divide data into equal parts or based on the certain position in the array. Let's see how to use this split function to divide the array. Here I am going to create a variable data, and it is going to store array. Then I am going to call np.arange, and then generate data from 1 to 7. And now next to it, print the data, execute the cell, and you can see here we have a one-dimensional array, and this array contains 6 elements. Now let's say you want to split this 1D array into equal parts. So for that, here you can specify np.split function. Remember, here you can store into another variable, but I'm not going to use that. I will show you directly how to use this np.split function in the cell. So here within this split function, specify the array that you want to split into equal part. Here it is a data, and after this specify comma, and then you need to specify the equal parts. Suppose you want 2 equal parts, 3 equal parts, or 4 equal parts. So in this case, I am going to split the array into 3 equal parts. I will specify 3 here. And as soon as you execute the cell, here we have 3 arrays, and you can see each array contains 2 elements from the original array, and thus you divided or split the data into a 3 equal part. Remember, to divide a one-dimensional array into equal parts, first specify the array that you want to divide or split, and after this specify the number of equal parts. So in this case we want 3 parts, so we specified here 3. As you can see in the output, this split function split the array into 3 equal parts, but here we have not stored this array in a variable. Let's store this array into a different variable. So here you can specify x, y, z, then equal to. So whenever you execute this cell, then it is going to store all 3 arrays into these 3 variables separately. So if you execute this cell again like this, and now if you specify here print x, execute this, now here you have the first array or the first sub array. Then again print here y, this contains the second sub array, and similarly if you print here z, this contains the third sub array. So this is how you can use the split array to split the array into a different parts and then store those parts into a different variable like this. So here you learn how to divide the array into equal parts by specifying this integer value within this split function. You can also split the array based on the indices or index of the array. So if you remember, this is the array, and as you know, the index of the first element is 0, the index of the second element is 1, index of the third element is 2, and index of fourth element is 3, and so on for the next element in the array. So here specify np.split and then specify the array that you want to split based on indices. So in this case it is data, and now instead of integer this time specify square bracket, and here you need to provide a indices or index based on you want to split the array. So in this case I want to split based on the index 2 and then index 4. Now execute the cell, and here we have 3 arrays. You can see this is the first array, this one is the second, and this one is the third array. So what is happening here when we specify 2 index here, 2 and 4? So this line splits the array into a 3 sub arrays, one from start to index 2, and then another from index 2 to index 4, and then last from index 4 to onward. Which means if you go up here and you can see this is the array, and here the first sub array is extracted from index 0 to index 2, and then another sub array extracted from index 2 to index 4, and then last sub array extracted from index 4 to onward. You can see here in the result set. So this is how you can specify indices to extract or to split the array into a different parts. Now we applied this split function on the one-dimensional array you can see here. Now let's apply this split function on two-dimensional arrays. So here I'm going to create a data3 variable, and this data3 variable will store the two-dimensional array. So in this case I'm going to create an array, and here it is a two-dimensional, so specify square bracket, and within this specify arrays. So first one is 1 and 2, then we have a second array which is a 3 and 4, and we have a 4, this is the 5th and 6th, and lastly here we have 7 and 8. And now print this data3, and we get the error because here it should be comma not dot. Again execute the cell, and now here we have a two-dimensional arrays. To split this two-dimensional arrays, specify here np.split, and first is the array that you want to split. So in this case it is a data3, and after this specify comma, and here we want to split this two-dimensional array into 2 equal parts, so specify here 2. And now remember, it is a two-dimensional or multi-dimensional. You can specify axes like a rows and column, how you want to divide or split the array into 2 equal parts. So here I want to specify axis equal to 0, which means this array will be divided into 2 parts along rows. Execute the cell, and look, here we have the array, and you can see at the output np.splits divide the 2D array along the row wise, and you can see each sub-array contains a 2 rows. So this is the first sub-array, and you can see this array has 2 rows, 1, 2, 3, 4, and this is the second sub-array. You can see this second array contains 2 rows, 5, 6, and 7, 8. So this is how you can split the 2D arrays into equal parts based on the rows. Similarly, you can split the array based on the column. So here specify np.split, then data 3, and then we want to divide this into also 2 equal parts, but this time based on the column. So specify x is equal to 1 here, and now execute this and look at the output. You can see here with x is equal to 1, np.splits divide the array along the column, and each sub-array contains a single column from the original one you can see here. So this is how you can use the split function to split the 1D or 2D arrays along the specified axes. So I hope that you understand how to use this split function. Next, we have a function in NumPy called np.sort function, and this function sorts the element of an array and then returns a new array with the elements sorted in ascending order by default. It can handle sorting in multiple dimensions like 1D, 2D, 3D, and more dimensions. Let's see how to use this sort function. So here I'm going to create a 1D array. So I will call array 1D, then equal to np.array, and here I'm going to enter a random number like 3, 1, 5, 2, 4, and you can see here there is no specific order of the element within the array. Now we are going to sort this array. For that, specify here np.sort function, and then to this function pass the array 1D that you want to sort, and now execute the cell. You can see this is the result, and you can see this time array is sorted in ascending order. Ascending order means it sorts the element from smallest to largest. You can see within the array, first element is the smallest element, which is a 1, and last element is the largest element, which is a 5. This is how you can use the sort function to sort the one-dimensional array. Now let's see how to sort the 2D array or two-dimensional or more dimensional arrays. Here I'm going to create array 2D equal to then np dot, and here I'm going to use random.randint. Then here it is going to contain element from 1 to 20, and then shape will be 2 rows and 2 column, and next to it I'm going to print this array 2D and execute the cell. Here we have a 2D array, but you can see the element within this array is not sorted. So let's sort the element. So here specify np.sort, and then to this sort function pass the 2D array, which is the 2D array 2D, and after this you can specify the axis along which you want to sort. So in this case I'm going to specify axis equal to 1, and remember within sort function when we specify x is equal to 1, which means it is going to sort this 2D array along rows. So now execute this and look, this array is sorted along the rows. Here if you look row wise, you can see first element is the smallest and second element is largest in this rows. Similarly, you can see in this second rows first element is the smallest and last element is the largest. So it sorts the element in ascending order along the rows. Similarly, if you want to sort the element along the column, you can specify here np.sort, then the array 2D, and then here specify x is equal to 0, and now this time this x is equal to 0 represent column. Execute the cell, and now here you can see 9 and 14. You can see here 9 is the smallest and 14 is the largest. So if you look vertically or column wise, elements are sorted from smallest to largest. Similarly, if you look at the second column, elements are sorted according to the column and from smallest to largest. So this is how you can use this sort function to sort the 1D, 2D or multi-dimensional arrays in NumPy. In this section, you will learn about indexing, slicing, and assigning NumPy arrays. Let's start with the indexing. So what is indexing? Indexing in NumPy allows you to access and manipulate individual elements, rows, and columns, even sub-arrays within the array. Let me show you how we can perform indexing. So here I'm going to create an array variable and then specify np.arange to generate arrays. So here I'm going to generate array from 1 to 10, and next to it print array, execute the cell, and we get the error because we need to import this NumPy. So here above specify import NumPy as np, and now execute this. Here we have a one-dimensional array. So array has a index, which means the element within the array has a specific index. For example, this 1 has an index 0, and this 2 has an index 1, and this 3 element has an index 2, 4 has a 3, and 5 has a 4, and so on for all the element. Let me show you how we can access each of the element using this index. So here specify the array and then specify a square bracket, and within a square bracket you need to specify index of any element that you want to access. For example, here randomly I am giving the index value as 3 and execute this, and you can see here we have the element 4. So if you go here within this one-dimensional array, you can see the index of 1 is 0, index of 2 is a 1, and then index of 3 is 2, index of 4 is 3. So here we have specified index as a 3, so you can see here the element 4 has index 3, so it returns 4. Similarly, you can specify any of the index, like you can give here index as 0, and it is going to return the first element you can see here. Similarly, specify index as 2, and you can see it returns 3, which means this 3 value has an index of 2. So this is how you can access the each element within one-dimensional array using the index. Similarly, let's create a 2D array. So here specify array 2D, which is equal to np.random.randint, and here it is going to store number from 1 to 20, and as you know it is a two-dimensional or 2D, so specify tuple. Here this array is going to contain 2 rows and 3 columns, and next to it print this array 2D like this, and now execute this. Here we have a two-dimensional array with a 2 rows and 3 columns. So first I'm going to show you how you can access each row using indexing. So here specify array 2D, then square bracket, and here within square bracket first thing you will specify is the row. So here 0 represent the first row, and then specify colon. So maybe here you have confused, so here before the comma you specify rows, and after the comma you specify columns. So here I am saying select the first row. As you know, here this is the row, and as you know this is the first row, so index will be 0, and this is the second row, so index will be 1. Similarly, this one, if you look vertically, you can see this is the column. This 7 and 3 is the column, so the index of this column will be 0, then this is the second column, then index of this column will be 1, and this is the third column, so index of this third column will be 2. So within this array we first specify the row, and then after this comma we specify column. And here remember, this colon means select all the columns. If you specify column here in a place of 0, this means select all the rows. Now you understand how to perform indexing on two-dimensional arrays. So let's execute the cell, and here now you can see we have the first row 7, 13, 6. You can see here this is the first row. If you want to access the second row, just specify index of second row, which is 1 in this case, and execute this. Now here we can access the second row, you can see here. Similarly, if you want to access column wise, like you want to access 7 13 39 6 3, just remove this one and specify colon here, and here you need to specify 0th index, and this 0 index represent the first column. And when you execute this, now here we have the array 7 13. If you go vertically, you can see 7 and 13. This means we are accessing column. Similarly, specify 1, then we can access the second column 13 9, and then specify column as a 2. We can access the third column 6 and 3, you can see here. Remember, before the comma we specify rows, and after the comma we specify column. Now you know how to access each rows and column of two-dimensional array. Let's learn how to access each of the element one by one. So here specify array 2D, and this is the array we want to use for indexing, and then specify square bracket. As you know, first element or first value should be rows value, so here I'm going to specify 0, and then second value should be column. I'm going to also specify here 0. Execute this, and now it returns 7. And if you look within this array, 7 is the first element, which means the index of the first element is a 0 0, which means this element exists at index of 0 row and at 0 column. Similarly, if you want to access the second element, only second element, what you will do here we are accessing the first row. As you can see here, this is the first row and the index of first row is 0. So don't change this, because here we have specified 0, which means this is the first row. Then we want to access the element within the second column. You can see here 13 and 9 exist in second column, so here specify 1, and now execute this. Look, it returns 13, and this is the second element in the first row. Similarly, if you want to access the third element in the first row, just change this to 2 and execute this. Now we can access the third element within the first row. Now you want to access the 13, and now this 13 exists in the second row, and as you know, the index of second row is 1, so specify 1 here. And now this 13 is the first element in the second row, so specify here 0, and now execute this. Look, it returns 13. Let's say you want to access this 9 element, and this 9 element exists in the first row, so we will specify index as 1, and you can see this 9 exists in the second column, so specify index as the 1 and execute this. Now we can access the 9. Similarly, you can access this 3, specify here 2, and now we can access the last element. So this is how you can perform indexing in two-dimensional using the concept of rows and column. Next, let's learn how to perform negative indexing. As you can see, while specifying index, we have specified positive index to access value. We can also specify negative index. So above here we have created this array. Let's first print this, print array, and as you know, this array is a one-dimensional array. You can perform indexing in backward direction using the negative sign. So here, if you have confusion, as you can see here, this is the last element. The index of the last element is -1, then second last is -2, and this one has a -3, and this sixth element has a -4 index, and so on up to the first element. Let me show you how we can access that. So here specify array and then square bracket, and if you specify -1, then it is going to return the last element. Execute this, and now we get the last element. Similarly, if you specify here array square bracket -2, then it is going to return second last element, and you can see it is 8, and look, this is the second last element within the array. So you can use this negative sign to perform a negative indexing, or you can perform indexing in backward direction from 9 to 1. Similarly, you can perform a negative indexing with a 2D array. Let me show you how we can do that. So here we have array 2D, and suppose you want to access this 3 element, so you need to specify here 2D array, which is array 2D, and then square bracket. And here the index of the row becomes -1. In this case we are going from backward direction from 3 to 7. Then here this is the second row, and the index of the second row becomes -1. So here specify -1, and when you execute this, you can see it returns the second row. And if you want to access the last element 3, and as you can see, this 3 element exist at a third column, but in case of negative indexing it becomes a first column. So here specify -1, and now execute this. Look, it returns 3 because this is the last element and we are accessing element in backward direction. So here -1 means in backward direction this is the first row, and this -1 means accessing the first column because we are going in backward direction. So this 6-3 becomes first row, 13-9 becomes second row, and 7-13 becomes a third row. If you want to access this element like this 1-9, then you can see this exists in the second column. So specify here -2 and execute this. Look, it returns 9. Similarly, if you want to access 13, then specify here -3 and execute this. You can see it returns 13. Why I have specified here -3? Because in backward direction this is the third column. If you want to access 6, and now you can see this 6 exists in the second column according to backward direction. So here instead of -1 specify -2, and now it exists in the first column in backward direction. So specify 1 here and execute this. You can see we have accessed the 6th element. Similarly, this 13 exists in the second column, so change this to 2, and now you can access the 13. And lastly, if you want to access 7, just specify here 3 because the 7 exists at the third column according to backward direction, and execute this. You can access the 7th element. So this is how you can perform a positive or negative indexing to access element within the one-dimensional and two-dimensional array. Now you understand how to perform indexing. Let's understand a slicing. So what is a slicing? A slicing allows you to access a range of elements or sub-elements in an array, and it has a format, and here in this format you specify array, then square bracket, and within square bracket you can specify start, stop, and step. So what is this start, stop, and step? So here start means it is the index to start from, and stop is it is the index to stop at, and remember it is exclusive, which means this value is not included in the range of element or sub array. And then step is the interval between elements or gap between elements. Now let's see how to perform a slicing with 1D array. And if you remember above, we have created this 1D array name array, and as you can see this array contains 9 elements. And suppose you want to access all the elements from 2 to 9. So what you will do here, you will specify array and then square bracket, and here you want to access all the elements from 2 to 9. So here the starting index or start value will be 1 because the index of 2 is 1. So specify 1, and after this specify colon and then execute the cell, and look, it returns all the element from 2 to 9. Similarly, if you want to access the element from 6 to 9, then here specify array square bracket, then the start index. So here the index of 6 is a 5, so specify here 5 and then colon and execute this, and look, it returns all the element from 6 to 9. Now suppose you want to access the range of element. For example, you want to access element from 2 to 5. So in this case you will specify here array, this is the array name, and then look the index of the starting element. So here in this case we want to start from 2, so index of 2 is here 1, then colon, and after that we want to stop at 5, which means we want to access all the element from 2 to 5. So here specify the index as 6, and now execute this, and look, it returns element from 2 to 6, but here we need to access element only from 2 to 5. So remove this 6, specify 5 here, and execute this, and look, it returns 2 to 5. Now suppose you want to access element from 5 to 8. So here in this case the index of 5 will be 4, so specify here starting index as a 4, then column, and then we need to specify stopping index. So in this case we want to access at 8, so specify index as 8 and execute this, and look, it returns all the element from 5 to 8. So here we have used the two parameter or the two concept, start and stop. You can also specify the third parameter, which is step, and in this case it specify the gap between element. For example, you can specify here array, then square bracket, and if you want to start from the beginning, just leave the first value as empty and specify colon, and also we want to keep empty the second value, which is the stop, so specify colon, and then after this colon you can specify step. So in this case we want to give a space as a 2, which means there will be gap of 2 between each element. So if you execute this, and here we get 1 3 5 7 9, and if you compare this 1 3 5 7 9, let's go up, you can see it start from first element, then it skips the second element and include the third one. Similarly, it skips this fourth one and include the fifth one, and so on for the element. So in the result set you can see 1 3 5 7 9, because here if you add 2 to this one you get a 3, and when you add 2 to this 3 you get 5, when you add 2 to this 5 you get 7, and when you add 2 to this 7 you get 9. Similarly, if you specify here 3, execute this, and now look what it returns. So it starts from the first element, which is 1, then you add 3 to this first element, you get 4, and then you add index 3 to this 4, you get 7. So this is how you can use this step to specify the interval between the element in your range of arrays or in a sub arrays. So this is how you can perform a slicing in a one-dimensional array. Now let's see how to do slicing with two-dimensional arrays. So here I'm going to create an array value, and this array value is going to store two-dimensional arrays. So in this case I'm going to use the arange function, and this array is going to contain 30 values. And as you know, this part is going to create a one-dimensional arrays. To convert this one-dimensional arrays into 2 dimensions, just specify dot, then call the reshape function if you remember. And to this reshape function, pass here, we want to create an array with 6 rows and 5 columns, and next to it print array value. Execute this, and now you can see here we have a two-dimensional arrays, and this array contain a values from 0 to 30 or 29, and the structure of two-dimensional array is 6 rows and 5 columns. So in previous section in indexing you learn how to index or access the element. So to access the element of two-dimensional arrays, you can specify array name, then square bracket. And now, as you know, before the comma you specify the rows, and after the comma you specify column. So in case of slicing we are going to use the same concept, but before that I want to show the index of rows and column. So here this is the first row, so the index is 0. This is the second row, index is 1. This is the third row, index will be 2. Fourth row, index is 3. Fifth row, index is 4, and sixth row, index is 5. And let's also see column wise. You can see this is the first column, so the index will be 0, This is the second column, index will be 1. This is the third column, so index will be 2. This is the fourth column, so index will be 3. This is the fifth column, so index will be 4. And now we will use this concept like rows index and column index to perform a slicing. Okay, with this array, you can see here before the comma you can specify row index, and after the comma you can specify column index. So here in this case we are going to perform a slicing over this array value. So here if you specify colon before the comma, which means select all the rows, and if you specify colon after the comma, then this means select all the columns. And if you execute this, look, it returns all the arrays. And suppose you want to access row from first row to the third row. So this area is a row indexing. So here you need to specify the starting of the row or starting index of the row. So here I will keep this empty. So here empty means start from beginning. And after this colon, specify the stop value, which means where the rows indexing should stop. So in this case, I'm going to stop at third. So I will specify here 3. And now execute this. You can see here in this array, we have only 3 rows. And look, it start from first and stop at the third rows. Now, after the comma, you can see the colon, and this colon represents select all the column. So in this result we can see all the column. This is the first column and this is the last column. Now if you say here start from the second column, and as you can see here the index of second column will be 1, so specify 1 here and select up to the last column. So I'm going to keep the empty this stop value and execute this, and look, it select column from 1 to the last. Now suppose you want to select only up to 4 column. So here you will specify 4. And now execute this, and look, it only selects from 1 to 4th column. So in this case, this is the first and this is the 4th column. So this is how you can perform a slicing over columns and rows. Suppose you want to start the slicing from the second row, you will specify here start value as a second. So this means it will start a slicing from second row and stop at the third row, and then it start a slicing from the first column and stop at the 4th columns. And now execute this, and you can see here we have the sub arrays or range of element from the 2-dimensional arrays. So look at 11, 12, 13. So we got this part of the array 11, 12, 13. Now suppose you want to access this part of the array like 23, 24, 28, 29. So here you can see this is the 5th row. So specify here start from 5th row and then go to the last row. So remove this 3 from here. Now look at this 23 exists within the 4th column and the index of 4th column is 3. So specify here 3. And then we need to choose all the element after this column. So remove this 4 and keep this empty and execute this. Now we are able to access 28, 29. So what is the mistake here? We want to access 23, 24, 28, 29. So we start from 5th row. So in this case we have specified the index as a 5, but it should be 4, and execute this. And now here we have the element 23, 24, 28, 29. Remember here indexing start from 0. So in this case the index of this 5th row is a 4, not a 5. So we specified here 5, we get only 28 and 29 in the previous result. So this is how you can perform a slicing over 2-dimensional arrays. Moving next, let's see how to assign value to Numpy arrays. We have created 1D, 2D or 3D arrays. Let's see how to assign value to these 1D, 2D, 3D arrays. So here I'm going to create a array variable, and then it is equal to np.array, and first I'm going to show you how to assign value to a 1D array. So here I'm going to create 1D array, and this array will contain series of number 1, 2, 3, 4 and 5, 6, and next to it print array variable, execute the cell, and here one-dimensional arrays. And as you know, index of this first element is 0, index of second element is 1. So here we can specify array variable, then specify the element that you want to access. So in this case I want to access second element, so I will specify index as a first. And now if you specify here equal and specify new integer value like 4, then at this index or at the first index it is going to assign a 4 value, which means here you can see at a first index we have 2, but as soon as we execute this line, after that it is going to contain 4 at the first index. Let's see. So here execute this, and now print the array variable, execute this, and look, this time it has a value 4. So this is how we can assign a different value based on the index within the array. So you can see with the help of indexing, here we are assigning 4 value to the first index. Similarly, you can specify here array variable, then a square bracket, specify 5, then equal to, and say here 10. So here it is going to assign value 10 at the 5th index within the array variable. Now next to it I'm going to print array variable, execute this, and look, at the 5th index we have the value 10. So this is how you can assign a value to 1D NumPy arrays. Now here you can use the concept of slicing to assign a value. For example, you can say here array variable, and then here you can say start from first and then end at 4, and here you can say assign 0, which means this line of code is going to assign a 0 value from the index array 1 up to the 4. So next to it print array variable and execute this, and look, it start from index 1 and up to index 4 it assigns value 0. So this is how you can utilize a slicing while assigning the value to 1D NumPy array. You can assign a different value at this position. For example, I'm going to copy this one and paste here. Then instead of 0, I'm going to specify 3 values. First is 12, 13 and then 14. And now execute this cell, and look, from the index first up to 4 we have assigned these 3 values 12, 13 and 14. So this is how you can assign a value to a 1D arrays in NumPy. Let's see how to assign value to 2D arrays. So for example, here I'm going to create array var 2D, then equal to np.arange, and it is going to contain value from 10 to 20, and I'm going to reshape this array, and this array is going to contain 2 rows and 5 columns. Next to it print array variable 2D, execute the cell, and here we have a 2-dimensional arrays. And as you know, to access the element of 2-dimensional array, you need to specify rows and column. So before the comma, if you specify row as 0 and column as 0, then you will be able to access the first element of the array. If you want to access the second element, then you need to specify here column as 1, and look, it returns second element. So how we are going to assign a different value at each index or at rows and columns? Here you can see row 0 and column 1 represent the second element in the array. You can specify here equal sign and then assign a new value like a 20 and execute this, and let's check the array. Specify here array var 2D and execute this, and now look, Here the second element has a value 20. Similarly, you can use here concept of slicing to assign a value. For example, you can see this is the first row. So how we can access the first row of 2D array? And that is very simple. Specify here array var 2D, then square bracket, and as you know, index of the first row is 0. If you specify here 0 and execute this, you will be able to access first row of the array. And now if you specify here equal sign, and as you can see in the first row we have 5 element. Let's assign a different 5 element here, like 1 2 3 4 5. So these 5 elements are assigned in the first row that we see here. Now next to it, let's print array var 2D like this and execute the cell. You can see the first row has a different value, 1 2 3 4 5. So you can use this concept to assign a different value row wise. Similarly, you can assign a value column wise. For example, you can see here this is the last column, and last column contain 5 and 19 value. Let's change it. So here specify array var 2D, then square bracket, and specify colon, then comma. So before the comma we specify colon, which means select all rows, and here specify 4, and as you know, this is the last column in this array. So if you look column wise, this first column has an index 0, this one has an index 1, this one has an index 2, this one has an index 3, and this last column has index 4. So after the comma we specify 4 to denote or represent the last column, and then equal to, and as you can see this column contains 2 values. If you specify here 2 values like 10 and 20, and next to it print var 2D, execute the cell, and look, the last column value changed to 10 and 20. So this is how you can assign a new value to array using the concept of indexing or a slicing. Next topic is a fancy indexing. So what is a fancy indexing? Fancy indexing allows you to access a multiple element of an array using an array of indices. So instead of using a simple integers or slices, you can specify arrays or list of indices to access elements of the array. Let's see with an example how fancy indexing works. So here I'm going to create a fancy array variable, and then specify np.array, and within this I'm going to create a one-dimensional array, and these array values are 10, 20, 30, 40 and 50. Next to it, print this fancy array, execute the cell, and look, it is a one-dimensional array. Now here, if you want to access the element of array, you can specify index like this, fancy array square bracket, and specify index of array like 2. So here fix the spelling and again execute this, and look, it returns 30, which means at index 2 there is an element called 30 in this array. So here the index of the first element is 0, index of second element is 1, and then index of third element is a 2. So here fancy indexing means you can specify array of indices. So what you can do here, instead of a simple integer, you can specify array of indexes. So specify square bracket and then say here 1, 3 and then 4. So when you execute this code, it is going to return element at first index, at third index and at fourth index. Execute the cell, and now look, it returns 20, 40, 50, because within this array you can see 20 exists at the first index, 40 exists at the third index and 50 exists at the fourth index. So this term is called fancy indexing, because here you are providing multiple indexes within a square bracket, or providing multiple indexes as a list or as array. Next, let's see how fancy indexing works with two-dimensional arrays. Here I'm going to create an array data and then it is equal to np.random.randn, and then it is going to contain values from 1 to 10, and it is going to be two-dimensional. So this array will contain 3 rows and 3 columns. Next to it, print array data and execute the cell. So here we have a two-dimensional array with 3 rows and 3 columns. Now to access the element of this two-dimensional array, you can specify here array data, then square bracket, then comma. And as you know, before the comma you specify rows, and after the comma you specify columns. So here you can specify list of indices. So to specify list of indices, specify square bracket, and within a square bracket you can pass multiple indexes. So here we are using fancy indexing before the comma, then it is going to apply on the rows only. Let's say we want to access the first and third row, so specify here 0 and 2, and after the comma specify colon, and as you know, this colon means select all the columns. And now execute this. Look, it returns first and third rows. Why? Because here we have passed the list of indices, and as you can see, this list contains 0, which is the first row in this two-dimensional array, and then 2, which is the last row in this two-dimensional arrays. So in the result set we get first and third rows. Similarly, if you remove this from here and instead of this specify colon and remove colon from here and paste that indices here, and now execute this, look, it returns first and last column. This is how you can apply a fancy indexing with the two-dimensional arrays. In this section you will learn about operation in NumPy, and here you will learn about 3 kinds of operation. First operation is the operation with comparison operator, then second operation is arithmetic operations, and third operation is a statistical operations. First, let's start with comparison operator. In NumPy, these are the comparison operators, and you are already familiar with. And these operators can be applied directly to arrays to perform element-wise comparisons. These comparisons returns a Boolean arrays where each element is either true or false based on the result of the comparison. This is useful for filtering, counting, or setting a specific element in the array based on the certain conditions. Let's see with an example. First, import the NumPy by specifying import NumPy as np. Execute the cell, and next let's create an array. So here I'm going to create an array variable, and then it is equal to np.array, and here I'm going to create one-dimensional array. So I will specify element 10, 20, 30, 40, 50, and next to it print the array, execute the cell, and here we have a one-dimensional array with 5 elements. Now first I will show you how to perform element-wise comparisons. So here we can use this comparison operator like a greater than, less than, equality, is not equal, greater than equal to, less than equal to. So first I'm going to use the greater than operator. So here I'm going to create a variable result which is equal to, then here I will perform comparison. Here I am going to say check if array elements are greater than 25 or not, and then next to it print result, execute the cell. Here we get the error because here it should be array, and now again execute the cell and we get the result. And as you can see in the result set, we have a boolean values false and true. So if you analyze this result, you can see here each element is true if it is greater than 25 and false otherwise. So here what happens, this line compares 25 with each element within this array. If the element is greater than 25, then that element is marked as a true, you can see here. If the element is not greater than 25, then those elements are marked as false, you can see here. So in the definition you can see here, these comparison return boolean array. So you can see in the output it returns boolean array, and where each element is either true or false. You can see here it denoted each element is either true or false. So here let's take one more example, and this time let's use the less than operator. And here again I'm going to create another variable result2 which is equal to, and then again comparing array is less than 30, and next to it print result2, and now execute the cell and look, again it returns boolean array where each element is marked as either true or false. So you can see here first two elements are true, which means first two elements are less than 30 that we have specified here in the condition, and after that all the elements are false because all the elements is greater than 30 in this case. So this is how you can specify the comparison operator. Let's take one more example, and here we will use the equality operator. And now here I'm going to create another variable result3 which is equal to array is equal to 20, and next to it print result3. Now execute the cell and look, again it returns boolean array, and here in this boolean array again each element is represented either as a true or as false. So you can see the first element is false because first element is not equal to 20, and then you can see second element is true because in the array if you look second element is 20, so this condition becomes true, then it is assigned a true value, and after that all the elements are marked as false because all the elements are not equal to 20. This is how you can use the comparison operator to perform element wise comparisons. Next, let me show you how you can perform filtering using these operators. So here I'm going to create a variable filtered elements, and this variable will store all the filtered elements. Here I'm going to specify array, then a square bracket, and within this square bracket we can specify these comparisons. So here I'm going to say filter all the element that is greater than 25 like this, and then next to it print filtered elements. Execute the cell and look, it returns only those elements which are greater than 25. So here you can specify conditions or comparisons within the square bracket to filter the elements from the array. Here I want to mention one thing. NumPy allows you to combine multiple conditions using a bitwise operators, and these bitwise operators are AND, OR, and NOT operator. So let's use this operator to combine multiple conditions. Here I'm going to create a filter elements, and then it is equal to array and specify square bracket, and within this I can include the multiple condition using these bitwise operator. For example, here I'm going to say array is greater than 20, then specify bitwise operator like and after this specify another condition array is less than 50. And remember, you need to wrap this condition within parentheses, so wrap like this, and now next to it print filter elements. Execute the cell and look, it returns array containing 30 which is greater than 20, and then it returns 40 which is less than 50. So here you can see we have combined multiple condition using this AND operator. Similarly, you can use the OR operator. For example, you can specify here array equal to 10, then instead of this AND specify OR, and also change this condition, it should be greater than 40 like this, and now execute this. Look, again it returns 1050. As you can see in this array is equal to 10, so it included the 10, And also you can see here array is greater than 40, so this condition returns element which is greater than 40, so in this case it is 50. So this is how you can use the bitwise or operator to combine multiple conditions. Now you learn how to filter elements from the array using the comparison operators. Moving next, let's understand arithmetic operation. In NumPy, arithmetic operation can be performed directly on an arrays, and these operations work between arrays or between an array and a scalar value or a single value. And basic arithmetic operator and function in NumPy includes addition, and you can use this plus operator for addition or corresponding add function within the NumPy. You can use the subtraction operator to subtract arrays or corresponding subtract function in NumPy. You can use the multiplication operator to multiply arrays, or you can use the multiply function in NumPy. You can use this divide operator or corresponding divide function in NumPy. You can use this double asterisks for exponential, or you can use this power function in NumPy. Also, you can use the modulus operator to find the remainder when you divide two arrays, or you can use this mod function in NumPy. Now let's see with an example how to use these operators or function. So here I'm going to create an array 1 which is equal to np.array, and here I'm going to create a one-dimensional array, and this array is going to contain values 1, 2, 3, 4, 5, and then next I'm going to create one more array. This is the array 2, and this is also going to be one-dimensional array, and here it is going to contain value like 10, 20, 30, 40 and 50. Now execute this, and here we have the array 1 and array 2. Now let's perform addition. To perform addition, here specify array 1, then specify operator plus, and then specify array 2. So this code is going to combine array 1 and array 2. When you execute the cell, you can see result. You can see here 1 is added to 10, then it becomes 11, 2 is added to 20, then it becomes 22, 3 is added to 30, then it has become 33. So this is how you can perform addition between two arrays. Or what you can do here, you can use the add function. So specify here np.add, and to this add function pass the array 1 and array 2, and when you execute the cell, look, it returns the same result. So here you can use either plus operator, or you can use the add function to add two arrays or more arrays. Now next, let's see how to perform subtraction. To perform subtraction, you can specify here array 2 minus array 1. You can see here we have used this subtraction operator, and when you execute the cell, look, it returns the result, and you can see from array 2 we are subtracting the array 1, and you can see in the result when we subtract 1 from 10 we get 9, so in the result set it is 9. For the second element, from 20 when we subtract 2 we get 18, so in the result set you see 18, and so on for all the element. Also you can specify here subtract function from the NumPy, and then pass the array 2 and array 1 like this, and when you execute this you get the same result. Now next, let's see how to multiply two arrays. To multiply two arrays, you can specify array 1, then you can specify this asterisk, which means it is going to multiply two arrays, and after this specify this second array, and when you execute the cell, look, it returns result 10, 40, 90, 160, 250, because when you multiply two arrays, the first element of the first array is multiplied with the first element of the second array, and you get the result. Similarly, you can use your np.multiply function to multiply two array. Specify here array 1 and then array 2, and when you execute the cell you get the same result. You can use either this operator to multiply or use this multiply function. Now next, let's see how to divide two arrays. So here I'm going to divide array 2 by array1. And here you can see to divide the array I have used this slash, and when you execute the cell it returns the result, and you can see each of the element of the array 2 is divided by each of the element in array 1. You can achieve the same result using the function np.divide in the numpy and pass array 2 divide by array 1, and when you execute the cell you get the same result. Next, you can find the exponential of all the elements within the array. So here you can specify array 1, then double asterisk, and then the power. So here power is 2, which means all the element within the array is raised to power 2. And when you execute the cell, look, it returns the result 1, 4, 9, 16, 25. You can achieve the same result by using np.power, and this function takes a 2 value. First is the array containing element that you want to raise to power, so in this case it is array 1, and second is the power that you want to raise, so in this case it is a 2. When you execute it you get the same result you can see here. Now you have the modulus operator, and this modulus operator returns reminder when you divide two arrays. For example, if you specify here array 2, then this percent symbol and then array 1. So after dividing array 2 by array 1, it returns reminder. When you execute this, you get reminder 0. And now you can achieve same result using the function np.mod, and here specify array 2, then array 1, and execute the cell. We get the error because remove the e from this mod function, and now execute it, you get the same result. So this is how you can perform arithmetic operation in a NumPy with arrays or between arrays. And one thing here I want to mention that here I have above mentioned that you can multiply an array with a scalar value, which means here we have array 1, and if you look at the element of array 1, it is 1, 2, 3, 4. So you can specify here array 1, and you can specify plus operator, and you can specify any scalar value like 1 and execute this, and look, 1 is added to each element of the array. So you can see here when 1 is added to 1 it becomes 2, when 1 is added to 2 it becomes 3, and so on for all the element. You can use any arithmetic operator here, like you can use multiplication, you can use here division, whatever the operator you want to use, you can use that operator perform that operation. So I hope that you understand how to use the arithmetic operators or arithmetic functions that exist in NumPy to perform arithmetic operations. Moving next, let's see how to perform statistical operation in NumPy. It has a various function to perform statistical operation, and let's explore some of the function. Here we have created array 1 and execute the cell. You can see this array contains 5 elements. You can sum all the elements of this array using the function called np.sum in NumPy. And to this function you need to pass this array containing all the elements. So pass array 1, and when you execute the cell you can see it returns 15, which means sum of all the elements within the array is 15. And whenever in statistics, when you want to sum all the element or all the data, use this sum function. Next we have the np.prod function, and this function returns the product of all the element in an array. So you need to pass the array like array 1. Now execute the cell and look, it returns 120, and this 120 is the product of all the element within the array 1. Next we have the function np.min function, and this function finds the average of all the element in the array. So you need to pass the array within this function and then execute the cell. Look, it returns 3.0. So the mean or the average of all the element within the array 1 is a 3.0. Similarly, NumPy has a function called np.std, or which stands for standard deviation, and when you pass array 1 to this function, then this function finds the standard deviation of all the elements in array. Execute the cell. Look, it returns standard deviation 1.4 for all the element within the array 1. Similarly, it has a function called np.ones, which stand for variance. So it finds the variance of all the elements in the array. So specify array1 and execute the cell. You can see it returns 2.0, which is the variance of all the elements in an array. Similarly, if you want to find the minimum element in the array, you can specify here np.min, and to this function pass the array1, and it is going to return the minimum element within the array. As you can see, minimum element is 1. Similarly, it has a function np.max function, and you can use this function to find the maximum value in the array. So pass array1 and execute the cell. Look, it returns the maximum value of the array, which is 5 in this case. Also, if you want to find the log of all the element in the array, specify np.log and pass the array1 and execute this. Look, it returns log of all the element within the array. So these are the statistical function, and you can use this statistical function to perform static operation. I hope that you understand what is a NumPy and how to create arrays, what are the functions that exist in the NumPy, how to perform indexing, slicing. Then you learn about functions in a NumPy like reshape, arrange, random, and then you learn what are the operations that you can perform with arrays. So these are the essentials thing that makes you ready for a data science or machine learning, and you will use this NumPy mostly in a data science or machine learning. And this is the end of the course, and at last I want to say, don't forget to subscribe my YouTube channel, and thank you.